Hello, and welcome to this episode of C++ Programming for Beginners. In this video, we will explore how your C++ program can make decisions using if, else if, and else statements. You will learn how to write conditions, handle multiple outcomes, and structure logic that reacts to the data in your program. Let's get started. So, as a brief concept overview with if-else statements, in C++, an if statement lets you run code only if a certain condition is true. You use if to check one condition. You use else if to check another condition if the first one fails. And you can keep doing else if until you run into an else statement, which is used to handle everything else. Think of it as a default. So we can see in our first example here, we are checking if a number is positive, negative, or 0. So on line 5 here, we are initializing a number. Then we are requesting a user to enter a number, and then we're taking that input in. So here is where the if else statements work. So first, we're checking to see if the number is greater than 0, or in other words, if the number is positive. If that's the case, we print out a statement saying it's positive. Else, if that's not true, we go down to this else if. If this is true, this block of code is executed, and then we move down to line 16. But if the number is not positive, we go to the next line, saying, well, trying to figure out if the number is less than 0, in other words, negative. So else, if the number is negative, it prints out this block of code. If neither of these two cases are true, we go down to this else statement, which is our default. But what this is saying is, if the number is not positive, if it's not negative, it must be 0. We print that out, and then we return 0. So this is a classic example of mutually exclusive paths. All three of these cases are completely separate from each other. But now that we explained the code, let us compile it. G++ example1.cpp, and let's call it x1. That's compiled. Now let's run it. Enter number. Let's start with a positive number. Now let's run it again. Running example 1. Let's enter -6 now. Now the number is negative. And let's run it for a third time. Let's just enter 0. And as you can see, it says the number is 0. Okay. Now let's go on our second example here, which is an even or odd checker. Here, we are starting out with a very similar thing, but we're checking to see if the number is even or odd. So here we only need an if and else. We don't need an if else because the number is either even or odd. Here we're using the modulo operator to check to see if the remainder of that value entered and divide by 2, if that's equal to 0. If that's the case, we print out that the number is even. Otherwise, it must be odd, so we print that the number is odd. So let us compile this one. And let's run it. Let's first enter an even number, like 6. As you can see, the number is even. Running this again, let's enter 7. As you can see, it says number is odd. So that works out correctly. This is a good example of a binary condition. So we only need an if and an else. So our third example is a grade calculator. So here we need multiple else if conditions to go through the many options possible. So here we are getting a score from 0 to 100. First, we're checking if the score is greater than or equal to 90. If that's the case, the user got an A. If not, it keeps going down. If it's greater than or equal to 80, you get a B. If it's greater than or equal to 70, you get a C. If it's greater than or equal to 60, you get a D. And then otherwise, you get an F. Because at that point, you are 59. The number must be 59 or below. Okay, let us compile this last example. And let us run it. So entering the test score, let's say first, let's do 95. As you can see, got an A. And then if we keep running this, let's do 85. You get a B. If you run it again with a 75, you get a C. If we put 65, you get a D. And then otherwise, let's do 55, you get an F. So again, this is a multi-branch decision tree. Conditions are evaluated top-down until one matches. And we avoid overlapping by checking from highest to lowest. So we're doing it in some order. That's very important. Before we end this video, let's go through some common mistakes and key takeaways. First, some common mistakes are to use the single equals instead of double equals. Like this, for example. Because remember, a single equal sign is assignment, double equals is comparison. Another mistake is to forget your curly braces around multiple statements and misplacing the order of else-if blocks. Just like our example 3 here, if we did this in a wrong order, you would get during testing you would get an incorrect response. So some key takeaways: if evaluates a condition and runs code if it is true. Else if lets you check additional conditions in order. Else captures any scenario not matched above. In other words, it's a default. You can structure your conditions from most specific to least specific. That's usually the best way to do it. And finally, conditional logic is the foundation of interactivity in your programs. You'll be using if statements a lot, especially in early programming. If you enjoyed this video and you got something from it, I would appreciate if you would give it a like. Comment, subscribe, turn on notifications. Thank you for watching, and have a great day.